All right, welcome in. Just wanted to record a short video giving an example of how to calculate the average atomic mass for an element if it has various isotopes. So these isotopes have different numbers of neutrons, which doesn't affect all of their properties, but it does affect their mass. So here we have magnesium, which has 3 naturally occurring isotopes. We have magnesium with a mass of 23.99. And this shows up 78.99% of the time. Our second isotope, let's do blue here. Yes, shows up 10% of the time and weighs 24.99 AMUs. And then our final isotope, what we want to do, we can do green, weighs 25.98 AMUs, shows up 11% of the time. So we need to perform a weighted average, add up the, mass of each isotope, but taking into account how often it shows up. So what we can do is we can say our average mass is equal to, the sum of these isotopes. We'll go one at a time. Our first isotope weighs 23.99, and we need to take into account, multiply by how often it shows up. This is the fractional abundance. We're given this number as a percent, but we do want to switch it to a fraction or a decimal instead. So we have this showing up 78.99% of the time. Just shift the decimal place 2 spots to the left to switch to that fraction instead of a percentage. A percent is per 100. We want to be per every 1. So 0.7899 times 23.99. All right. We want to continue doing our calculation here. We want to add this up, the same kind of idea, for each of our isotopes. So our second isotope weighs 24.99. AMUs. And this shows up 10% of the time. 10% written as a decimal is 0.10000. Let's keep the same number of significant figures. And then lastly, we have our magnesium with a mass of almost 26, 25.98. And again, multiplied by the fractional abundance, 11% written as a decimal, 0.1101. And our goal here, let's just do this addition. Let's get our value, figure out what that number is. And then we can think about our significant figures. So when we're doing this calculation, we certainly can punch this into our calculator all in one. I've broken it up into 3 steps. So this first number was 18.94. $9701. Calculator tells us a lot of digits. Okay. Our second number, our calculator told us 2.499. And this third number, we had 2.86. 0398. Great. So we can do this in multiple steps, and when we add them together, what do we get? Our final value here is going to be 24.309099, and our units are AMUs, so we have this many AMUs. We do want to take into account the number of significant figures, so here is one of those cases where we get to do both multiplication and addition. So let's follow along each step of the way. Our multiplication steps, we have to do the fewest number of significant figures. So here we can do some underlining. We have 4 significant figures times 4 significant figures. we know this value out to 4 significant figures. Same thing for our second value, 4 sig figs times 4 sig figs. Okay, we know this out to 1, 2, 3, 4 significant figures. Our third isotope, same story, 1, 2, 3, 4 significant figures. When we're doing addition, we want to keep in track of the decimal places. So when we had 4 sig figs, well, this accounted for 2 decimal places, as it turns out. Our second number, we had 4 sig figs. Well, this ends up being 3 decimal places. And our third number, also we're keeping track of the decimal places, ends up being 3. We want to, well, compare our decimal places. 2 decimals versus 3 decimals versus 3 decimals. We keep the fewest number. And so our final answer will round to just 2 decimal places. So this is what we're looking at. This is what we're looking at. We can round this. Okay, 24.31 AMUs as our final answer. Boom, perfect. Notice here, our weighted average is somewhere in between our 3 values. This is good, this makes sense. And it's skewed towards our most common value of 23.99, but dragged up to be a little bit higher based on these less common isotopes. Hopefully this helps. Let me know if you have any other questions, but otherwise, take care. See you next time. Thanks.